Okay, in this section, we're going to talk about measuring centers again. And we've talked a little bit about this already, but we're going to bring in a couple of extra ones here. So here are our learning targets. We're going to find and interpret the median of the distribution, which we've already kind of been doing. We're going to calculate the mean, which you guys maybe have done previously, but we're going to talk about a little bit, and then we're going to compare those and kind of figure out which one is going to be more beneficial to us. Okay, so how long do people typically spend traveling to work? So what they've done is they asked 20 people in New York how long it took them to get to work. And they did a dot plot of it. So here's the 20 responses that they got and how many minutes it took them to get to work. So here's the data that they collected here. And one of the ones that we're going to talk about, one of the measures that we're going to talk about is mode. Now, I'm sure you guys have talked about mode before. Mode is the one that most frequently occurs. So it's the one that shows up the most. Now, in this example right here, the mode is this guy right here. And it's not always a good measure of the center because it can fall anywhere in the distribution. So clearly, if the mode is down here around 15 minutes, that really doesn't represent the time very well of all of the commuters. 15 minutes is only representing the people in this area right here. So mode is not usually a very good one to measure our distribution around, but it is one that we talk about sometimes. So mode is the one that occurs the most often. It repeats the most often. The median is the one that we've been talking about. Now, median's in the middle. Now, I want you guys to get a little bit lazy on this one. We've been doing this for a while, so this one's not going to be too hard. But here's one I want you to get a little bit lazy on. We already know that it's the midpoint. It's already in the middle. We already know all that. Here's what I want you to do. If we know that our list of numbers is an odd number, then the median is going to be in the very middle. If our list of numbers is going to be even, then what we're going to do is when we start counting from both ends, we're going to have two numbers in the middle. We're going to have to average those. So we add them together and divide by 2. So kind of make this a little bit easy on yourself. So if you know that you have an odd number in the list, you know you're going to have one number in the middle. If you have an even number in your list, you're going to have 2 in the middle. You're going to have to average them together. So the median is what we've been talking about so far. Half is going to be on the left, half is going to be on the right. Now, the easiest way to do the median, again, we write them from smallest to largest, so it's easier to do. Okay, so here's some data. These are talking about the amount of fat grams in fish and chicken sandwiches on the McDonald's menu. And the first thing that you're going to want to do is let's write them in proper order. So go ahead and take a second here and write these down in proper order, small to big. And then start by finding the median. So they tell me right here that we have 9, which is an odd number, so I know that I'm going to get one number in the middle. So we're going to start crossing off. So 6 and 40, 28 and 17, 19, 26, 22 and 20, 21 is the middle. Now, what does that really mean, though, to me? So again, n was an odd number. We knew there was going to be one number in the middle. But what does that really mean? That tells me that about half of the data is on one side and half of the data is on the other side. So of McDonald's fish and chicken sandwiches, more than 20 that have more than 21 grams of fat, half of them won't, and half of them will. So it's pretty easy to read right there. Okay, back to our opening question where we were talking about the 20 people that were giving us our work travel times back at the beginning. Let's find and interpret the median here. Now, we can do this from the dot plot. That's totally okay to do, or you can write these out as a single line of data from small to big, whatever you want to do. I think the book went ahead and wrote them out as a line so that you could cross them off, but you guys know we could do this as well. You could just go in there and cross off like that. So it really comes down to what you want to do. Now we know that there's 20 data values, so that means that we're going to have 2 left over in the middle. So we're going to have to average those guys together. So go ahead and find the median on these guys. So go ahead and find the median. Pause the video if you need to. So here are the numbers listed out if you want to write them out, or if you want to just cross them off on the dot plot, that's fine. So after you crossed everything off, you should have gotten 20 and 25 or the leftover numbers in the middle. So all we have to do to find the median is to average those two together. So we're going to take 20 plus 25 and divide that by 2. 20 plus 25 divided by 2 gives me 22.5. So that is the median of our data. So that tells me half of the workers in the sample travel less than 22 and a half minutes to work, and half of them travel more than 22 and a half minutes to work. That's what the median is going to give us. All right, now the next one is the mean, and I'm sure you guys have heard of this before. The mean of a distribution of a quantitative data is the average of all the individual data values. So what that means is we're going to add up all the values and then divide by the total number. So I think you guys have done this previously. So if we have in data values, we're going to add them all up. Now, this is some new notation right here. I want you guys to pay attention to this. We use this quite a bit. It's X bar. So it's got an X with a bar above it. So it's pretty easy to see. It's called X bar. Now, the formula says the sum of the data values. So we add up all of our data values, and then we divide by our total. That's what this formula is saying right here. I add up all my data values, and I divide by the total. N is the number in my data. Now, this funky looking thing right here is a Greek letter. That is the capital letter for sigma. Sigma just means sum, which means add things up. This means add up the numbers in your data. So the top part is literally saying add up all of the data. And then this says divide by how many ever numbers are in your data. So the mean is the average. That's what we're doing right there. All right, looking at a new example here. How many runs does the Lawrence High School baseball team usually score? So this is the big thing right here. Here are the data on the number of runs scored by the team in all 21 of their games played during the recent season along the dot plot. So they gave me the dot plot, and then they also wrote out the numbers for us. So you guys, again, you can write the numbers out if you want, or you can just pull them off of the dot plot. It's totally up to you how you want to do it. First thing that we want to do is to calculate the mean number of runs scored by game during the season. Okay, so we're going to start by adding up all of our numbers and then dividing it by 21. So go ahead and pause the video real quick here. Calculate the mean by adding up all the numbers and dividing by 21. Okay, when you added up all the numbers, we should have gotten 87 divided by 21 gives me about 4.14 runs per game. So that's about how many they should have scored on the average there. Part B says the dot plot suggests that the game in which the team scored 12 runs is a possible outlier. So they're saying this piece right here is an outlier. It doesn't really fit with the rest of the data. So what we're going to do is we're going to actually cut this off. We're going to cut that piece out, and we're going to refigure our data. We're going to our mean. We're going to refigure our mean and figure out what happens. So when we refigure our mean, we're taking that piece of data out of it. So now I have one less term in my data. So if we had 87 in our sum previously, and I'm taking out 12, and we had 21 games, but I'm taking out 1, we should have 20. Let's go ahead and find the new mean. And then what I want to know is what happens then. We already should have a pretty good idea of what's going to happen, but then what does that really, what's the whole interpretation of that? What does it mean? So we got the new total is 75 over 20. So the average now is 3.75 runs per game. So what does that really mean to us, though? What do you notice about that? How does that play into anything here? Why did I have to mess with the outlier? Oh, sorry. The team's 12-run game increased the mean number of runs scored per game by 0.39 runs. So that outlier pulled the mean out farther away from the median. So it pulled it. The mean, when we had the outlier, got pulled. It threw it off a little bit because of that outlier out there. So this is one of the reasons that we don't necessarily use the mean when we talk about the measure of center. It's not resistant, which means an outlier throws off the mean. It doesn't throw off the median, it throws off the mean. So a measure of center is resistant if it isn't influenced much by an extreme value in a distribution, also known as an outlier. So on that one with the baseball, if I took off that outlier, our mean was much more reasonable. But when we put the outlier back in, it really stretched it out. It really threw it off a little bit there. Now the median is resistant. So the median is the one that we want to work with here, because it's not really affected by any outliers, because remember, the median is just in the middle of the data. So it doesn't really matter what the data is. It's just going to be in the middle of it. So in the runs scored, the middle of the 21 games is 3. So it doesn't matter if the last number is 12 or 120. It doesn't make any difference at all. The median is still going to be 3. It doesn't affect it because that outlier is there. It's still going to be a good center. If we remove the possible outlier, the median is still going to be 3. So if I took the 12 off, I would still have a median of 3. It doesn't affect it at all. It's resistant to the outlier on that one. But the mean was not. It changed. It changed significantly. Okay, if we go back to our baseball example here, for the data on runs scored in each game by that baseball team, the dot plot balances at X bar equals 4.14 runs. That's the mean. So comparing the mean and the median, which one should we report as the center of distribution? Well, that kind of depends on the shape of the distribution and whether we have any outliers, because the shape is definitely going to change which one we use, and outliers is for sure going to depend on which one we use. So let's take a look at when should we use the ones. Should we use the mean? Should we use the median? Do we ever use the mode? That's what we should look at right now. Okay, the mean gets pulled in the direction of the long tail in the skewed distribution. Okay, so let's check this one out here. We have a skewed left on this example right here. The tail is on the left over here. So what happens is the mean is getting dragged closer to that tail. The median doesn't move. It doesn't matter if there's an outlier on the left or not. It's still going to be in the middle. So when we look at this, let me get rid of my marks here. So when we look at this example right here, it says that the median is 19 and the mean is 17.89. The mean is moving towards the left because that's where the tail is going. So when it's skewed to the left, the mean is going to be smaller than the median. It's getting pulled that way. All right, if we look at the skewed to the right, the tail again is on the right-hand side here. This example says the median is at 3 and the mean is at 4.14. So the mean is getting pulled to the right, so it's bigger than the median. but that doesn't necessarily represent all of our data. Again, it's getting pulled tail. Oh, sorry, and the mean is going to be greater than the median on that one. Now, the ones that are roughly symmetric, the mean and the median should be about the same. So we should have about the same data on the left and about the same data on the right. So this example right here, we've got the median at 15.8 and the mean at 15.78. So these guys would be, either one would be a good one to use for this particular one because it's basically symmetric on both sides. So we want to stay away from the mean. If we're doing any kind of skewed data, it's not the one that we want to use. We want to use the median. And if it's roughly symmetric, then we can get away with either one of those. Okay, so how do we choose a measure of center then? How do we know? With our quantitative data, if it's roughly symmetric and it doesn't have any outliers, we're going to use the mean usually. If it's skewed one way or the other and it has outliers, we're going to use the median. So that's how you're going to know which one to go with. So roughly symmetric, has no outliers, we're going to use the mean. If it's skewed, has outliers, we're going to use the median. So again, going back to our New York workers here, we found that the median was about 22.5, it looks like, and the mean was 31.25. I want to know, explain why the mean is so much larger than the median. So why is the mean bigger? What do you think? Why is the mean bigger than this? Well, hopefully you said that it's because it was the right skewed and the mean was getting pulled to the right. So the mean was moved to the right. It was getting pulled to the right skewed. Also, we had a possible outlier here around 85. And so the mean definitely would be affected by an outlier. The median, not affected by an outlier. Mean, always going to be affected by an outlier. So which measure of center better describes a typical travel time to work? Which one do you guys think would be better, median or mean? Well, hopefully you guys picked median. So 22.5 minutes better summarizes the center of our distribution. 31.25 does not reflect the typical. I mean, they're showing us here only this many people took longer than 31.25. That is not the same amount of data that we have over here. It's getting pulled to the right. So again, that's why we do not want to use the mean. So watch for skewedness, watch for outliers on those. All right, you should be able to get onto your assignment to check for those. Be careful on outliers, be careful on skewed, and good luck on it. You can do it.